Hello guys, welcome back. And today we are going to solve hard problems that is the upgrade versions of the last daily question. That's mathematical number of the target nodes after connecting trees. Version 2 is the hard versions. So the difference between this and this one and the medium one is the statement had trained that node U is target to node V if the number of edges on the path from U to V is even. That is like path length like 0 or 2 or 4 or 2 multiple k. That's the even number. And another difference is that the length constraint here is quite huge, like 1 million. Mm, just on other statement, detail is the same. So what's different here? The main idea is the same as peer problem. That is to first we need to find the maximum, the node that target to as most node as the as most other nodes at most the other node as possible. Okay. First we need to find that node in the tree two. So easily connect from a node to that. Um, and also on the tree one, we also need to find the for each node find how many nodes this node target to. Okay, that's the main idea, but the limit is too large, so we cannot do the for to the solution and power two and n is the maybe time complex time limit is 6 and we are so we need to find solutions that only like work in on linear time. And as you can see that the statement has changed to an easier versions that is only even that we don't need to take care about the exactly uh, the total length of the path. Okay, first let me try with an example first. Let's draw some symmetry like like this. Okay. Mm, yeah, as you can see, when for example, I start at node this node zero is zero, and enrich the level of this the level the one, the distance e1, and this the line two, and this line three. Now let me draw more, blah 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 more, so can easier to understand like that. This is four. We call this in graph theory we call this depth depth of the node. Yeah, because it's a tree. Yeah, it's not a normal graph, so we can use the depth here. And you can see that it's like the BBF tree, like to reach the length of one. So one, then next level is two and three and four, and so on. And now you can see that the answers, the total answer of the first node here is uh, this, and this, right? It's on the node, on the depth of an even number. Like, do you see this one, and this one? So we totally have one, two, three, four, four. The answer is four. Okay. Um, what if I told you that on the node in the depth in the even depth had the same target node like the root one? Okay, let's take this. As we know that this is at even depth, so it travels back to this with even with the number of edge even, right? Like this is one or two, the same as this, and this is travel back to another this this level. The different is two, so it's be like the depth that we call it the depth of node U, like the U to target like depth V is even. Okay, even this. Okay. uh, I say, for example, you want to travel from this to this, okay. If you want to travel from a node to another node, like it will cost you the cost of go to the what we call it lowest common ancestor, come to the parent and go down to that node. So it totally cost you like depth of u uh, plus the depth of like depth of v. Yeah. So, so the case in the case you travel from a branch to another branch, it will cost you the sum of two depth. And the case you travel from this branch to the node inside the same branch, it's gonna be depth u minus the difference between this. And all of this, okay, and all of this have the same formula that is it is also like is even yes even too. So in con in in conclusions, we only care about the modulo of this one because if you know some math, you maybe you be two equal to zero. That is even less, right? Call it the A and B. So it must be the A to plus B2 equal to zero, like that, like that. So it's model two, like A minus B two is the same as equal to zero in the mode two. So even if the plus or not, this is like okay. So this so that it must have the same what like we call it the parity. Yes, parity is also the same too, like this. Yeah. So it will be like 1 0 with the can be like one to have this sum. It must be like 0 and 0 or 1 with 1. So it's gonna get the sum of sum two in modulo two. So so that's I prove that all the nodes with the same with the same parity level have the depth has the same parity depth have the same answers. Okay, let's take this. From this node you can go to this and like this and this and this. So it's totally the same as this. Okay, that's mean it can reach 1 2 3 4 4 1 2 3 4 5. Yeah, also this can reach 1 2 1 2 3 4 5. Yeah, 5 sorry, 5 1. It's not 3, it's like it's 2. Sorry, I draw it wrongly. I draw it from wrongly. This one. Okay. So the same here. So all we need to do is find only two case, that's it, even and odd, to find on the node on the node can reach the root with even step and odd step. That is, and count using yeah, we only need to care about the same parity depth node. So what we're now going to do here is to do to derive the derivative of derivative two times to one time to find that's the number of to define the level the depth of it's not on a tree. Assume that node zero is the root or whatever node is not important, and the answers is and the answers for the node as even depth uh, is the same, and at odd depth is the same too. So we need to count the number of odds and even that is the on the tree one, on the tree one and the tree two, and do the same. But we only need to care about two value. The two we can do the above two times like no need, no, we don't need to do two times. We only do one to count the number of nodes on even level. This is one of it. Even level and odd level. Let's go. Hope you can understand what I say. It's just about mathematics. And the main concept here is to is we know that to a node at the root of the tree and do the BFF to define the level, BFF to define the level, the depth, sorry, the depth of the tree, and the node that have the same even or odd level, you have the same answers as I proved here. That I proved is here. Yeah, so all we need to do is just to find this odd and even node. So that's why. So we need the equation magic like this, and write some derivative functions, derivative function. You can like do turn the pair that you parent like that. So let's do count the depth here. Depth plus one, right? Plus one. Okay, the first step to count on, and then we also need to on the tree two is don't care about it, but on the tree one we need to care about it, so we must like deal with two times like use to these parameters like that to a form. This is press 0 0 and this Jason right first and second count on the even and odd note. And for this case, we're gonna do something like if that one plus something like that, something like that. Plus, okay, now do df def and turn press. First, we need to like create the edge and want to save the space. I only use one. This tracing, do the better tracing for side two. Tracing is side, tracing is side, and do on the 3 second first. Like view edge 2 0 1 indirect graphs of respect to edge, okay, after that we're gonna do the debug on the root and the root like tracing not no zero and not one stand no parent depth 0 and like these answers 3 2. Okay, yeah, 3 2 west, and this mask in 3 2 west, mapping 3 2 west first and 3 2 west second. Slow down to check it. Okay, so now we do sign. So M no, oh, this is M no, and this is the N replaces empty. Do the same as the note 3, the note 3 1 1 and 1, and this is N. Okay, we got a 3 2 here, and we're gonna do some two new parameters to reuse function. Then we may want to reuse these functions. No, I'm gonna write two functions to like follow the single responsibility principle. Alliances that virtual tuition tuition tuitions like u e and like yeah, like that. Okay, yeah, yeah, true. Another thing we need to draw here like the mask in 3 2 to don't need to okay. Vector answers here, answers reside and right. Okay, we do the first derivative to find the in 3 1 breaks derivative notation 0 1 dot trees where reside. Now we need to care about I travel from the node to this. We can choose two options to from a node with edge with even or travel node with arch whatever. Okay, like you choose to this one, you may reach the even node in this tree, the arch node in the tree, or if you choose another one, oh you may reach like this node in the same level, the odd level in the original tree. But like let us make sure that we need to count the number of nodes on the tree. Like if only we have one node, so we must we don't have odd and even here. Okay. It's not important because it's maybe zero. Okay, it's not important. 1 3 3. Okay. It's important. Why? For example, you have one node, you have a tree, like this, and you have a tree, a node like this. You only have one node, so you cannot go this and got one. You must go to another edge and reach to one. So it's still not affected the general solution, but if we only have one node and one node, so there's no way to connect this, right? Okay, let's check this is the S case. We need to check. It's gonna be 1 1. So check and 0 and plus so to 0, we want to return some 0 0. Oh, what can do is 0 0. Okay, okay, that's true. Now find the answers. We need to do the band again. Answers equation B U. Yeah, plus 1 in 3 2. That says and the answers of the node U is maybe oh no, not in 2 and you must understand this more. too many parameter here, and I don't like it. Three one west. Okay, three one west. Something like this. Three one west. And it's used like if that one, so it must get from the view three one west first as the mass in three two. That's it. Else as is view go to three one west second. Let's map in three two. That's it. So that's the five answers. Jason, so my one, and return the answers. Whew. The answers. I see. And two on this. Oh, it's correct at the first try. Let's test another case like we only have one edge on this and this young only have one edge two. And another case, that's case this and this. So another case is 0, 1, no, no, and another no, no, like this and this. Test the same case as this, and also this. This on test case we need to test out. It's on code. Oh, so we don't have this case. Oh my gosh, we don't really care about it. They really don't care about it. Okay, so we don't really care about on this case. So make it more easy. Yeah, submit. Yeah, 100%. Okay, have a nice day. Hope you have today solution of me bring you some new ideas and price of a new day. Goodbye.